Organic chemistry. Topic name is resonance. These are the learning outcomes and we are learning the characteristics of resonance and resonating structure. So the resonating structure of any molecule is just an imaginary structure. It do not have real existence as individual species. So we can say that they cannot be prepared in laboratory. This is a point to be noted. None of the resonating structure can be prepared in the laboratory. However, their resonance hybrid structure, we can say that they are the real structure of the molecule. Okay. Now, due to the resonance phenomena, the bond length in resonating structure exhibit equal values, so they become equal. Here in this figure, you can see three legal moves of resonance. So, you should know these moves, the rules to prepare the resonating structure of any molecule. In this lecture, in upcoming slide, we will also see the correct way to make resonating structure. So here you can see that the pi bond breaks into a lone pair, okay, and the head, where the head of the arrow is there, it shows the negative charge. Okay, so head of the arrow have negative charge and its tail have the positive charge. So a pi bond breaks into a lone pair, and similarly a lone pair can be used to make a pi bond. Okay, also we can also shift the in the third structure. Please see that we can also shift a pi bond to its adjacent bond. Okay, and a positive charge remains in other one, okay, other atom from where the bond is moved. So these are the characteristics and some kind of rules of resonating structure. Now the point which I have said that due to the phenomena of resonance, the bond length in resonating structure exhibits equal values or they become equal. We can see this point by a example. So in the case of benzene, it's a resonating hybrid structure. The carbon-carbon bonds are not alternate, okay? They are not in a alternatively single and double bond position. Rather, all of them are intermediates of single and double bond and the bond lengths are equal. Please see the hybrid structure of benzene, not the resonating structure. So here you can see the intermediates of single and double bonds, and the bond length of all is equal. Now, the resonance hybrid has lower energy and thus have the greater stability than any of the contributing structure. Now, this point can be understood by this example. For example, if you have eaten some food which is providing you energy, let's say a energy bar, then you want to play or you want to do something, okay, so you are not stable at that time because your energy is high. But in a opposite case, when you are feeling low in energy, then you don't want to do anything, you want to sit somewhere and relax a bit. So that means that whenever you will have low energy, at that time you will have greater stability. So same thing happens in molecules also, because the resonance hybrid structure have low energy, so it have greater stability. Okay, or we can also say that greater the resonance energy, greater is the stability of the molecule. Now don't mistake the resonance energy with the normal energy. Resonance energy is different. It is the difference of energy between the resonating structure having the most energy and the hybrid structure. Okay, so in the case of resonance energy, we say greater the resonance energy, greater is the stability of the molecule, and for it we should have lower normal energy. So this was the important point of characteristics of resonance. Now next point to be noted is For the resonating structure, the position of the nuclei must be the same in all structure and the total charge must also be constant. So the thing which moves is only the electrons, okay? The lone pair or the negative or positive charge. The position of nuclei remains the same, okay? And the total charge in all the resonating structure is constant. It will not be a case that in one resonating structure we have something else charge and in the other of the same molecule we have different charge. So the total charge will always be constant, but their position can be, the position of the charge can be different, okay? The structure, those structure which have little contribution where negative charge is on less electronegative element, okay? Now all the resonating structure, they must have the same number of unpaired electron, and the structures with similar charges on adjacent atom are insignificant due to electrostatic repulsion and the consequent instability. We all know that the resonating structures are very unstable because of the higher energy. Now, resonance structure with greater number of covalent bond are more stable. Now, if you have to compare a structure with great number of covalent bond than other, then you can find that the molecule with greater number of covalent bond will be more stable, okay? And more stability means less in energy. So, the non-polar structure of formic acid is more stable than any of its resonating structure. So, here I have shown you a figure showing the resonating structure of formic acid. So, you can see resonating structures are not that much stable because they are polar structure, but the hybrid structure, which is non-polar, is more stable, okay? Now, the last point for the characteristic of resonance is that the charge separation structure are less important than those in which the charge is delocalized. So, this is a condition for resonance. The structure where charge can be delocalized will be more important, okay, than the charge separation structure. And the reason behind is the electrostatic attraction between the unlike charges, as you can look in this figure, okay? Now next topic is the correct way of moving electron. Here I have given you some examples, and now in this example you can find out the correct way of moving electron in a resonating structure. You can also know how to make resonating structures of molecule. So in the first structure you can see that there is a carbon bonded with two hydrogens and one carbon, and it also have a lone pair and a negative. Lone pair means it will have a negative charge on it, all right? So now you have to move the lone pair to the adjacent carbon. Why? Because you can't move the lone pair from oxygen. The reason is, if you will move the lone pair from oxygen to carbon, then this carbon will have 5 bonds, right? So this is not the possible case, okay? Now if this does not happen, because this does not follow the octet rule. You have studied that for resonating structure one should follow the octet rule also, right? So we will move the lone pair from carbon to the adjacent carbon, then it will have double bond between the carbons, and the bond between carbon or oxygen will break it into the formal charges, and oxygen will have a negative charge on it, right? So this is the correct way. Similarly, here in this figure you can see that the nitrogen is having lone pair, and because it's more electronegative also, so this lone pair will make a bond between carbon and nitrogen it will have a double bond, or we can say a pi bond, and nitrogen, because it have given its lone pair, it will have a plus positive charge. In the third figure, again, the lone pair from nitrogen will make a bond between carbon and nitrogen, and the bond between carbon and oxygen will break and oxygen will get negative charge. Here also the lone pair from oxygen will not make a bond between carbon and oxygen, because then again the carbon will have 5 bonds which do not follow the octet rule. Okay, then the carbon will have in total 10 electron, okay, which is not possible, and nitrogen here will have a positive charge. In this slide I have shown you how not to move electron. I have explained this thing already. Okay, now let's talk about the questions related to this topic. Question is, you have to state true or false. Greater the resonance energy, lesser is the stability of the molecule. No, this is wrong. The stability of the molecule will be greater. So the answer will be false. Second question is that which of the following is correct for resonating structure? You have given some statement and you have to find the correct statement. So for resonating structure, it is said that they must have same number of unpaired electron. It's true. Next is the structure with similar charges on adjacent atoms are insignificant due to the electrostatic repulsion. This is a good point and this is true. And third is they have consequent instability. Yes, resonating structure are comparably or relatively unstable than the hybrid resonating structure. So all of the above for this resonating structure statement is true. And these are the topics which we have covered in this lecture. Thank you so much for watching this video.